Hi everybody, and welcome to the last part of our notes for Unit 3. And today we're going to be talking about masses and percent composition. All right, so first up we want to talk about what's known as formula or molecular mass. All right, when calculating the formula mass, and we use the term formula mass technically for ionic compounds. All right, or molecular masses, and molecular masses because molecules are technically covalent compounds. All right. We're going to be using the average atomic masses from your periodic table. Now, while technically these two things get different names, formula mass and molecular mass, the process to solve for it, it's exactly the same. So something really important to remember as you do these molecular masses is that you are going to always use a tenths place, all right, when it comes to these average atomic masses on the periodic table. So let's start out with a nice, easy example, and that's water. All right, so water has hydrogen in it, and it has oxygen in it, okay? Hydrogen, if I look on my periodic table, has a mass of 1.00794. So I'm just gonna round that to 1.0, okay? Oxygen has a mass of 15.9994. That rounds to 16.0. All right, hydrogen, there's 2 hydrogen atoms in my water, so I'm going to multiply that by 2. There's only 1 oxygen, so that gets multiplied by 1. So this is going to be 2.0, 16.0. You add them up, and your answer is going to be 18.0. The label for this is atomic mass unit. All right, great. Okay, so next up, let's take a look at a little bit larger formula, and this one is for aluminum sulfate. Well, the first thing you need to do is you need to write the formula for aluminum sulfate. All right, so let's go on ahead and do that. Aluminum is a metal. It's on the left of the stair step, okay? It's not only a metal, it is a regular metal. We know the charge for it. So we can just go on ahead and figure out the formula. Here we go. Aluminum is +3. This is an ionic compound. Sulfate, polyatomic ion. I check the back of my sheet. All right, sulfate is SO4. It has a 2- charge, so that's 2-. Okay, so for aluminum is +3. Sulfate is -2. Least common multiple of 3 and 2 is 6. So how many aluminums do I need? I'm going to need 2 aluminums. So it's going to be Al2 parentheses because I need multiple polyatomic ions. SO4, and now I need 3 sulfates because 3 times -2 is -6. So there's my formula. All right, I now need to come up with my mass. So I'm going to write out all of my different compounds. We take this slow at first. Eventually, you're going to be able to do these very, very quickly. All right, so aluminum, sulfur, and oxygen are my 3 elements in this compound. Looking at the periodic table, aluminum has a mass of 27.0. Sulfur has a mass of 32.1. And as we stated earlier, oxygen is 16.0. But remember, we have multiples of these. Aluminum we have 2 of, so we're going to have to multiply that by 2. Sulfur, well, each sulfate just has 1 sulfur, but you have 3 sulfates, so that's 3 times the 1 sulfur, so you're dealing with a total of 3 sulfurs. Oxygen, each sulfate has 4, but you have 3 sulfates, so 4 times 3 is going to be 12. All right, now it's just a matter of arithmetic. 27 times 2, you have 54.0. Then you're going to get 96.3 here. And then finally 192.0. You add all of those up and you should get 342.3 AMU. All right. Go on ahead and please pause this video and go on ahead and write the formulas and the masses for these final 2. All right, so I'm going to go on ahead and do this. I'm going to do this pretty quickly. For my lead 4 phosphate, all right, so lead 4, that's telling me that it has a charge of +4. Phosphate is a polyatomic ion, again, on your sheet, with a charge of -3. All right, so when I write my formula, I have Pb Okay, a least common multiple of 4 and 3 is 12. So how many plus 4s do I need? I need 3 of those. How many minus 3s do I need? I need 4 of those. All right. When you end up doing all of this, you find that your lead is 207.2. You have 3 of those. Your phosphorus is 31.0. And you have phosphorus, there's just 1 in phosphate, but you have 4 phosphates. So you have 4 of those. Oxygen, which you'll notice is very common in these compounds. You have 4 in phosphate. There are 4 phosphates. So that gives you 4 times 4, which is 16. You're going to get, this is a large ionic compound here, 124.0 and 256.0. You're going to add those up and you get about 1001.6 AMU, all right, for our lead 4 phosphate. Okay, last compound that we'll do together, here we go, magnesium hydroxide. So magnesium plus 2, it's in group 2. Hydroxide, really important polyatomic ion. All right, hydroxide is -1. Okay, so I need 2 hydroxides to go with my 1 magnesium to give me a neutral compound. And here I go with my masses. I have magnesium, I have oxygen, and I have hydrogen. Magnesium is 24.3. All right, oxygen is 16.0, and hydrogen is 1.0. You have 1 magnesium, so that gives you 24.3. You have 2 oxygens, so that gives you 32.0. And you have 2 hydrogens, that gives you 2.0. You're going to add all of those up, and you get 58.3 AMU. All right. Okay, another thing that we're going to ask you while talking about these molecular and formula masses is we'll ask you questions having to do with percent composition. And it's really straightforward. All that means is what percent of the whole compound is a certain element. So for example, in your notes, the question that we give you is find the percent composition of oxygen, all right, for these 2 compounds that you have above. Okay, so let's look at lead 4 phosphate first. All right, and I'm just going to cover this up as we go. Okay, well, how much, so this is for our PB3PO4. All right, so how much oxygen do we have? Well, we found that we have 16, oxygen has a mass of 16. There's 16 of them. So the total oxygen that we have is 256.0. I'm going to divide that by my total mass. Okay, so 1001.6. So this is the mass of oxygen, of all of the oxygens, over the total mass of the compound. All right, and we do treat this as a percentage, so then I am going to take that and multiply it by 100, and you should, for that one, get about 25.6%. as your answer. Now go on ahead, please, and do the same thing for our magnesium hydroxide. All right, you can pause the video and then we will continue. So let's take a look here. Okay, so for B, I had magnesium hydroxide. All right, and I know from my work here, my oxygens were 32. My total mass was 58.3. I'm going to multiply that by 100, and I get about 54.9% oxygen for this compound. All right. I could have asked for magnesium's percent or lead's percent. It's just really dependent on how we want to treat it. Okay. The last thing we're going to be talking about in our notes is a special type of compound that you're going to be using in your lab. So please put a big star by this and write lab. When it comes time for you to watch the lab, you are going to be, you want to reference the notes right here. Okay. We're going to be talking about what are known as hydrates. All right. Hydrates are ionic compounds that actually have water molecules attached. This occurs all of the time. It occurs naturally. Water is very attracted to things that are charged. So water molecules will just adhere to certain ionic compounds. All right. When we use the word hydrate, you want to think water. All right. So let's take a look at the names and how we would deal with this. Okay. So cobalt 2 chloride pentahydrate. All right. Wow. That's a long name. Well, it's really two pieces. It's an ionic compound. All right. And then it's telling you your number of waters. Okay, so what do I mean by that? Well, my ionic compound is cobalt 2 chloride. All right, well, cobalt 2 means cobalt has a charge of +2. Chloride always has a charge of -1 because it's in group 17. So I'm going to write my ionic compound. CoCl2, great. Now here's the new part. I'm going to draw a dot. This dot is not a multiplication sign. Let me repeat myself. It is not a multiplication sign. It is a dot, all right? Now I'm going to look at my second part of my name, penta. All right, the prefix penta means 5. So this is telling me that 5 water molecules are attached to this cobalt 2 chloride, to a single cobalt 2 chloride. So I'm going to use a full size number, we call that a coefficient, in front of the water. That's the formula for cobalt 2 chloride pentahydrate. All right, we're going to work backwards here, and then we'll go back and do a little bit of math with it. All right, so here we go. Now it's a little star in your notes. It should be a dot. I just didn't know how to make it a dot when I was doing it, so I just wrote the star. So that should be a dot, so change that now. And let's name this, okay? So you're going to name your ionic compound. You're going to say to yourself, all right, magnesium, is it a metal or a non-metal? It's a metal. Is it regular or transition? It's regular because it's group 2. All right, so I just go on ahead and name, and I'm going to name it right up here. So it's magnesium sulfate, because SO4 is the polyatomic ion sulfate. Now I don't put a dot in the name. I just continue writing it. 7, the prefix for 7 is hepta. These are the same prefixes we use for your covalent compounds. And then we use the word hydrate for our water. So that is the name, magnesium sulfate heptahydrate. This has a common name that you might have heard of, and you might even have it in some of your medicine cabinets. This is Epsom salts, all right, that people often use in baths and things like that. Okay, so one thing that you're going to be doing in your lab is you are going to be determining the percent water in a hydrate. So what do I mean by that? Well, let's go back up and we're going to look at our cobalt 2 chloride pentahydrate. We're going to find the mass of the whole thing. So here's cobalt, here's chloride, and a little piece of advice, keep water as one thing. It's just going to make your life a lot easier later. So from the periodic table, cobalt has a mass of 58.9. All right. How many cobalts are there? There's just one cobalt. So that stays 58.9. Chloride has a mass of 35.5. There's 2 chlorides. All right. Water, and this is one you should know or just do in your head really quickly. Remember, oxygen is 16, hydrogen is 1 each, so 16 plus 2. Water, the whole thing has a mass of 18.0. And how many are there? There are 5 waters. All right. So what we're going to do is we are going to go back up. 35.5 times 2 is 71.0. And 18 times 5 is 90.0. We're going to add all of those up. When we add all of those up, we get 219.9. That is the total mass of what we say the hydrated compound. Hydrated compound. All right. So to figure out the percent water in this hydrated compound, what I'm going to do is I'm going to take just the water, that 90, and divide it by the total. So let me write that over here. 90.0, which is the mass of water, of all your waters, divided by 219.9. I'm going to multiply that by 100. That 219, remember, is the total mass. multiply that by 100, and I find that this compound is actually about 40.9% water. All right, great. Going ahead and try this on your own for magnesium sulfate. Please tell me what the percent water is for magnesium sulfate. You can pause, or you can go ahead and watch me fill this out. So magnesium, sulfur, oxygen, and waters, okay, is what I'm dealing with. Magnesium's 24.3. There's just one of those. Sulfur's 32.1, just one of those. Oxygen 16.0. There are 4 of those. Water's 18.0, and there are 7 of those. So this gives me 24.3, 32.1, 64.0, and finally 18 times 7 is 126.0. Add all of those up, and I find that it's 246.4. All right, that's my total mass. I'm then going to take just my waters, 126.0, divided by 246.4, multiply that by 100 because it's a percent, and you'll find magnesium sulfate heptahydrate is actually predominantly water. It's about 51.1% water. All right, again, please put a star by this because you are going to be using this when it comes to your labs that you're going to be doing. All right, have a great day, everybody.